Problem number 9. A small electric immersion heater is used to heat 170 gram of water for a cup of instant coffee. The heater is labeled 180 watts. It converts electrical energy to thermal energy at this rate. Calculate the time required to bring all this water from 23 degrees Celsius to 100 degrees Celsius. Ignore any heat losses. So in this question, we have to find the time taken to heat the water from 23 degrees Celsius to 100 degrees Celsius. So that means we have to find the answer for the time. So before that, let's be write the given, and after that we can find the answer for this question. So here you have the electric heater, and then in that heater how much water we took. So we took the mass of the water, the mass of water we took in the electric immersion heater 170 gram. So we have to convert this to kilogram. So 170 multiplied 10 power minus 3 kilogram. And then in that heater, its power is mentioned. So the power mentioned in the heater is 180 watt. And we are going to find the time. So the time taken to heat the water, from how much time needed to heat the water from 23 degrees Celsius to 100 degrees Celsius. So initial time T1 is 23 degrees Celsius, and then the final time T2 is 100 degrees Celsius. By using this, we can easily find the change in temperature delta T, which is T2 minus T1. So 100 degrees Celsius minus 23 degrees Celsius, we got the answer as 77 Celsius degree, not degree Celsius. I hope you understand now, right? Because you have to mention Celsius degree for change in temperature. And also you no need to convert this temperature to Kelvin, because it will also give the same answer. So we can take the value, because change in temperature in terms of Kelvin as well as Celsius will give the same answer. So this is the answer for delta T. Or you can mention the unit as Kelvin, no issue. Now by using this, what we are going to find, we are going to find how much time required to heat the water, to heat the temperature from 23 degrees Celsius to 100 degrees Celsius. So in the theory, we studied the rule, which is the power, conduction rate power, which is equal to the heat energy divided by the time. So by using this equation, we can easily find the answer for the time by rearranging this equation in terms of T. So therefore, T, which is equal to Q over P. But the heat energy is not given, but we already studied from the theory absorption of the heat by solid and liquid, which is nothing but the specific heat capacity. So that means the heat absorption by using the specific heat capacity value. So we studied the formula for Q, which is nothing but mc delta T over P, where m is the mass of the water, where c is the specific heat capacity of the water, and delta T is the change in temperature, where P is the power. Now we can easily substitute the value, because we already have all the values here. So let's substitute the value. The mass of the water here is 170 gram. So 170 multiply 10 power minus 3 multiply by, what is the specific heat capacity of the water? So the specific heat capacity of the water is 4187 joules per kilogram Kelvin. So I'm going to use this value. It's a constant, so you no need to worry about anything. This value will be given in the exam paper. So in place of C, C is the specific capacity of the water. So 4187 multiplied by delta T value is 77 over the power value is mentioned in the heater is 180 watts. So we have to find the answer now. So let's see what's the answer. 170 multiply 10 power minus 3 multiply 4187 multiply 77 over 180. Here we got the answer as 304.48. So the answer we got here as T equal to 304.48. So I can write 5, and the unit for the time is second. So this is the answer for this question. That's it. Thank you.